Hi guys, welcome to Time to React, our live stream. This is a pretty new format for us all, seeing as a result of the pandemic. Hopefully, this is a way where we can still get some awesome content out there, and also all do our own bit just to remain safe for ourselves, but also for the people maybe a little bit more vulnerable than us, that might get harshly affected by anything that we might be carrying on us and not even know. So I think this is just all doing our bit whilst still being able to stay connected in our community, and everything like that, and hopefully still have a really good evening, enjoying some decent content from some amazing people that I can't thank enough about how versatile they've been in order to make this happen. It was looking pretty dodgy this time, sort of earlier on last week when we didn't really know what was going on. But yeah, I think hopefully you guys are going to enjoy it. I do want to reiterate, and I might say this a few times, that you can please still be engaged as much as possible. Please comment as much as you can throughout the course of the presentations. Questions will be answered probably after the presentations. But if you do have any questions, please just fire away and we'll try and get around to all of them as soon as we can. We're going to be hearing from Arti Mathanda, who's an engineer at Simply Business. She's going to do a talk on React hooks. So excuse me, fingers crossed we'll be hearing from her quite soon. We've also got John Linnell, who works at Third Bridge as a senior engineer. He's got a lot of experience in React, and he's going to talk about is Redux Dead. Fingers crossed you can all see and hear me okay at the moment. The next voice you'll hear is going to be one of our presenters. So I'll just sort of switch over to them. This is the first time for me doing this as well, which is why it might be a little bit vague for you guys. But if you do have any questions, like I said, please just comment away. We also really want your feedback. So if you can shoot me through a direct message, either on my LinkedIn, my meetup page. I'll make all of those readily available for you on the comment section as well. I really do want to know what you guys think. If you're enjoying this format, if you think it's a waste of time and just wait until we can get back in the room because it's too much of me and not enough of everyone else, which is why you come to these things, then yeah, just give us some suggestions about how we can do it better, and then each time we can just kind of innovate. So enjoy the meetup, the meetup, if you will, and then I'll see you soon, very soon. But yeah, looking forward to hearing from this. So let's get started. Cheers.
Welcome to this unusual edition of Time to React. I hope everyone is safe and healthy. Today I'm going to talk about React hooks and also how and why to write your own. I know from past experience with Time to React that the audience here is pretty diverse, so there's probably a good mix of juniors, seniors, and mid-level engineers. This talk mainly caters to those who have at least a foundational knowledge of React and use it pretty regularly. Things change very quickly in our industry, so if you have any constructive and kind feedback for me, I'd be really grateful for it. So my name is Arti Mathanda. I am an engineer at Simply Business. You can reach me on Twitter or GitHub at Arti Smarty. I've been in the tech industry for over a decade now. I started off as a tester, and my last role before switching to engineering was as head of product for a small startup. I had been wanting to get into engineering for a really long time, and finally last year decided to make the leap. Currently, I'm working mostly with React, and I have the occasional adventures with Ruby and Rails. This talk was born out of really a personal desire to learn more about React hooks and how they work. And so I decided to volunteer for this talk because I knew that if I put myself out there in the public, that I would really make sure I knew I would really make sure that I would try to know what I was talking about. And so I'm hoping that from what I've learned, I can help you get a basic understanding of what hooks are, why you'd want to use them, how to write your own custom hooks, and why to write your own custom hooks. The two hooks we'll look at today, well, three if you count the custom hooks. The first two are useState and useEffect. And then the custom hook that we'll write is called useLocalStorage. So what are hooks? Hooks are just standard JavaScript functions that let you hook into React state and lifecycle features from functional components. Before React hooks was released about 15 months ago, you could not have state in functional components. So any component that you wanted state in had to be a class component. React hooks changes that, and now your components can have state. Your functional components can have state. So they're also backwards compatible. What this means is hooks are completely opt-in, and they contain no breaking changes. So your app and your existing state and lifecycle component code and classes will work as usual, and you don't have to go refactor them and add hooks and change them to functional classes, functional components, and also you cannot use hooks in class components. You can mix classes and functional components that have hooks together in a single tree, but you can't use hooks in a class component. Okay, but what are hooks? So let's take a look at our first hook of the evening. This is useState, which is, I think, probably one of the most commonly used hooks. As the name suggests, this is used to set up and manage state or states in your component. Let's take a look at a simple and somewhat contrived example. This is an app that renders two components that I've written. One is a class function component and one is a functional component. And it basically just shows you the X location of your mouse when you move your mouse over the each of the divs. So this was done, this is the class component, the code for the class component, and it's roughly 23 lines of code. And this is without constructors or binding, thanks to the relatively new class properties proposal. It's still pretty big compared to the functional component that we'll see in a second. This is the code that you should generally be familiar with, but we'll go compare both of them in a second. This is the functional code that does exactly the same thing. Already you can see it's much smaller, 14 lines of code, and arguably easier to read as well. So let's see what this is doing. So as we all probably know, we set state, we're tracking the state for the X location of the mouse. So we've set state and then defined the object, state object, and we have a location X and the default value is 0. For the functional component, we've got the useState hook. In this case, we're tracking, the thing we're tracking for state is location X. So the way we've defined the useState hook is location X, comma, set location X. Basically, the useState hook gives you a destructured array that has the value and the set value. So if you were tracking, say, name in your state, you would say name, set name. If you were tracking count, you would say count, set count, and so on and so forth. So that's the basic syntax to use for useState. The 0 is the default value when the state is created. And then this is the event handler, the function that tracks the actual X position of your mouse. And as you know, you use set state, this.set state to update the location. And in a functional component, you use set location from the previous use state that you had. And then finally, you've got the rendering of the component. As you know, class components have to have a render method. But in a functional component, you don't need that. And then the other difference here is that in your class component, you'd say this.state.location_x, whereas in the functional component, you can directly access that by saying location x. How about if you wanted more states? So let's say you were creating a Star Wars API, an app using the Star Wars API, and you wanted to create, you wanted to track planet name, character name, species name, actor name. You could do that like this. So you could say, have a functional component called Star Wars, and then track planet name, set planet name, character name, set character name, etc., and have a separate hook for each one of them. Obviously, this can get pretty messy if you're tracking a large number of states within the same component, but there's a hook for it, use reducer. I think John's going to go into some detail about this and Redux after my talk, so stay tuned for that. I'm not going to go into the use reducer state today. All right, so the next state that we look at today is the use effect state. So the use effect hook is basically the lifecycle methods that we have in class components. So component did mount, component did update, and component will unmount, kind of combined with slight differences. For those of you who haven't used lifecycle methods, component did mount is when a component is first rendered in your app. Component did update is when state changes in the component and it gets updated. And component did unmount is when it's removed from the DOM. The basic syntax for use effect is you call the hook, use effect hook, and it takes in a callback and an optional dependency array. The dependency array is what decides when to run the effect again. So basically, use effect will always run on a component when the component mounts. And you're telling the effect that after mounting the component, this dependency array has all the things I care about. So only run it when these things change. Let's see how that works. So in this first syntax, this will run every time. So beware, if your app has any state dependencies on other components, if those component states change, this component will also change and re-render. So you should be a bit careful about this because, I mean, in this example that we'll see, it's a really small app, so it's not a big deal. But if you have a component that's, like I said, very dependent on different other components for its state, then every time one of those components change, this will re-render. And in a big app, you can have some serious performance issues if you don't pay attention to that. And so this is how you would fix this. So when you use use effect with a callback and an empty array, it will only run on mount because your dependency array is empty, effectively telling the code that this effect is not dependent on anything else, so don't call it again. And then the third thing is use effect with a callback that takes in a dependency array with A and B, and then it'll only run after mount and if A or B change. This is finally the counter example that we're going to take a look at. So in this app, there's a counter which starts at 0. You can see that the counter is tracked in the title, and also when you click on any of the buttons, add 5, remove 5, reset, it changes the counter. So the code basically is doing this. So we've written a counter function which takes in a step prop, and we've got the state which tracks the count, so count and set count. The initial default value of state is 0. Um, we've got these functions that increase, decrease, or reset the count. And then we've used our use effect hook here, which says, hey, every time the count changes, update the document title. And then this thing here is what keeps track of the count from state. And then we've got all these buttons calling the increase, decrease, or reset functions. Let's see how this works in a class component. In the class component, we would have document componented mount and componented update. And so you'd have your document title being updated in either of those. And in the function component, all you have to do is use effect. And because you don't have a dependency array, it will run every time the count changes. We don't really want to do that. And so this is a safer way of doing it, where you have count specifically mentioned in your dependency array. And as you can see, it's exactly the same. Let's now take a look at custom hooks. So custom hooks are basically hooks that you write. So custom hooks have a couple of rules. One, don't call hooks from regular JavaScript functions, only call them from React function components. And you can also call your default React hooks from custom hooks. So for example, you can write a custom hook that calls useState or useEffect or useReducer or any of the other React hooks from any of the other hooks from the React API. The other rule is that when you write a custom hook, the name of the custom hook should always start with the word use. This basically tells your ESLint plugin that, hey, this is a custom hook, and make sure it's following the rules of hooks. So this is an app that we've written, which basically is helping you choose a song to remember how to wash your hands for 20 seconds. I picked this song, which is a modified version of Baby Shark. I apologize that it's now going to be stuck in your head for the rest of the evening. You can also, in this app, choose whether to view it in the light or dark mode. What happens, however, is that if you refresh the screen, then actually, let's take a look at how this is done first. So we've got, we've set the state here for mode and set mode, which is by default empty, the use state, the state value for mode. We've got another function here called change mode that when you click on the change mode button, it checks if the mode is light, and if not, then if it is, then it sets it to dark, otherwise it sets it back to light. So it is basically toggling the mode. We also have our use effect hook here, which updates the document title and tells the user what mode they've selected. And it's got the dependency array with mode in it. So it'll only update if the mode changes. We also got the main div, which decides the class for the CSS, so the light that I've written separately, which basically changes the background and foreground color. And this class name is either mode from the state, or if it can't find that, it defaults back to light. So as the name suggests, useState is a hook that's used to set up and manage state or states. So how does this work? Let's take a look at a simple and somewhat contrived example. This app is basically comprised of two components. One is a functional component at the top, and the other is a class component. And every time you move your mouse over either of the components, it updates the X location of the mouse. So this is how I've written the class component. It's roughly 23 lines of code. You're probably pretty familiar with this if you've written class components with state before. And remember, these 23 lines of code are without constructors or binding or super or any of that stuff because of the relatively new class properties proposal in JavaScript. And this is, the usual declaring the state object, then writing the handle mouse move function to update state, and then the render method. Let's take a look at how this would get done in a functional component. First of all, it's only 14 lines of code. It's almost half of the number of lines of code for the class component, and it's arguably more readable. Let's break it down and compare them together. So in the class component, you declare a state object and declare the key value pairs of each of your states that you're tracking. In this case, location X with the default value 0. When you use React hooks, the way you would do that is you would say const location X, comma, set location X equals useState 0. So what this is the useState hook returns a destructured array containing your state initial value and the set location and the set value basically. So in this case, you're tracking location. So you would declare useState by saying location, comma, set location. If you were tracking something else like name, so you would say names, comma, set name, age, comma, set age, etc. And yes, you would use a separate React hook to track each of these different states. And the 0, as I said, is in the use state is basically the default value for the location X. And I don't know if you notice that when the thing loads, it starts at 0 because that's the default value. The next thing is the function to update state. In this case, you say this.setState and you change the value based on what your event handler is sending you back. And then in the functional component, you would use the set location X to update your state. And then finally, rendering the component. Now, obviously, render has nothing to do with hooks, but we don't have a render method in functional components. And then the other difference is that you say this.state.location X in the class component, but in the functional component, you would say just location X. How about if you wanted to track more states? So let's say you wanted to use the Star Wars API to write some kind of app, and you wanted to track, say, planet name, character name, actor name, species name, whatever else. This is how you would do it. Obviously, this can get a bit messy, but there's a hook for it called useReducer. I think John's talk after this is going to go into some detail about Redux and possibly useReducer, so stay tuned for that. And that takes us on to our next hook of the evening, which is useEffect. So the useEffect hook is basically a kind of replacement for component lifecycle hooks, methods from class components. So component did mount, component did update, and component will unmount, all combined together with some slight differences. For those of you who haven't used lifecycle methods before, a really brief intro to it is component did mount is when a component is first rendered in your app. A component did update is when the state changes in the component and so it gets re-rendered. So that's component did update. And component did unmount is when it's removed from the DOM. So the way this works is useEffect is basically takes in a callback and an optional dependency array. The dependency array is what decides when to run the effect once it's already run on mount, which useEffect will always run on mount. So basically, you're telling the effect that after mounting the component, this array has all the things I care about, so only run when these things change. If the array is empty, it just means you only want it to run once, and that's it. Let's take a look at how the different ways to call use effect. Use effect with just a callback will run after mount and after every re-render. So beware, because if your component has any state dependencies on other components, this will re-render anytime those component states change as well. This is okay for the example that I'm going to show you, which is basically a counter, and so you're not going to do much damage. But if you have a huge app with complex dependencies, then be careful of this. And the way to prevent that is by declaring your use effect like this with an empty array and say, okay, just run after mount and don't run again. Just so you know, VS Code has a plugin. If you're using ESLint with VS Code, it won't let you use this as an empty array, and will use the state or whatever you're changing in that array. And we'll see an example of it in a minute. And then the third one is use effect with the callback and something in the dependency array. So in this case, you're saying, hey, run after mount, and if A or B changes, then run it again and call this effect. So let's take a look at this really simple app, which is basically a counter app that starts at 0. You can add 5, you can remove 5, and reset it. We are also going to update the document title when the count changes. So this is pretty simple component. We've written a counter func component, which takes in step as a prop. We've got the state here, which is count and set count. So it's going to keep track of the count as it changes. And the default start value is 0. We've got a few functions here that basically update, increase, decrease, or reset the count. And then here's our use effect hook, which tells the document title to update every time the count changes. And you'll see that our dependency array has the count in it, which is basically telling the document title to update every time the state of count updates. You also have your p tag there, count, tracking count, and you've got all these functions, buttons that call the functions. If we had to do this in a class component, we would have done it with component did mount and component did update. And as you can see, it's exactly the same thing, whether you use the class component or whether you use the state functional component. And then here, oh yeah, I forgot to mention that in this one, we don't have the count in the dependency array. And this is how it compares to the class component, because we're saying every time the component mounts and every time it updates, change the document title. And then here we're just safeguarding and saying, hey, every time count increases, change the document title. But if this component was dependent on anything else, state of anything else, then don't update it if that state changes. So now let's take a look at custom hooks. Custom hooks have a few basic rules. You should not call hooks from regular JavaScript functions. Call them from React functional components. You can call hooks from custom hooks. So you can use things like useState, useEffect, useReducer, etc. within your custom hook. Your custom hook's name should always start with a use, with the word use, because this basically tells your ESLint rules that, hey, this is a custom hook, so check that it's following all the rules that a custom hook should follow. So to give you an example of how we can use custom hooks and why, let's take a look at this really simple app that you've probably heard of this website called, I think it's called Wash Your Hands, where you can create a meme of different songs and to wash your hands to, so that you can remember to wash them for 20 seconds or more. So this app currently lets you choose the song lyrics, but also whether you want to see it, view it in dark mode or light mode. And you click the button and it changes the mode. So we've chosen the song, I've chosen the song Wash Your Hands, that is sung to the tune of Baby Shark, and I know it's going to be stuck in your head for the rest of the evening, and I apologize for it. It also updates the document title with the mode currently chosen by the user. So let's see how this is done using both state and effect, use state and use effect. First thing we've done in our dark funk functional component is to declare state, which is mode and set mode, and the default state is empty, or empty string rather. Then we've got this function that updates the state. So you've said it toggles the state basically. So if the mode is light, then change it to dark, set mode to dark. If it's dark, set mode to light. And then finally we've got our use effect hook, which is saying, hey, based on what the current value of the state is, update the document title to show me that state. And then we have a div with the class name that chooses which CSS to show, and therefore light and dark, etc. So this is great, but what happens is every time the user refreshes the page, the component has refreshed the default mode and doesn't remember what the user selected. And so let's use local storage to persist the chosen mode, and let's see how this is done. On the left, you have the previous code that we were looking at without all the the basic HTML to render it. And on the right, we've got the same thing, but this time we're using local storage. So the way that we do that is we first write a method called getState from local storage, and all this is doing is it's creating a variable called storage, which looks for the mode in local storage. If it finds that, then it returns that the mode. If it doesn't, then it returns the default mode, which is light. We also have another method that stores the state in local storage. So it takes in mode as the state, as an argument, and then it sets the local storage to that key value pair of mode and the value of mode. And then within our actual functional component, we've got the same thing as we had previously, but this time useState has a default value that it gets from local storage rather than declaring it manually. And then we still have the same change mode method, and then we've got our two use effects over here. One is to update the document title, and two is to store the state in the local storage when it gets updated. And so now with this, if we refresh the page, you can see hopefully that the mode doesn't change. What if we wanted to persist more than just the mode? For example, if we wanted to choose a different song to wash our hands to and have our component remember the song that the user has chosen, or the user's name, or anything else that we want to persist in local storage, that's where a custom hook would come in really handy. So let's take a look at how we can continue storing the mode in local storage, but make it generic so that anything else we want to store in local storage, we can reuse the code with our custom hook. So this is the code on the left without the custom hook, and on the right, it's with the custom hook. And let's take a look step by step at how we've kind of migrated over this code. So first thing you do is you declare const use local storage, and it takes in an initial key, a key and an initial value. And then we move the get state from local storage into the use local storage hook. And you'll see here that the main difference is that without custom hook, we're specifically going to local storage and looking for an item called mode. And with local storage, we're saying, hey, get me whatever key I've passed you. And if you find that key, then return whatever value is associated with that key. If you don't find it, then return the initial value. Next thing we've done is we've declared state with value and set value. And instead of in the previous example on the left, we've got mode and set mode, but here we're just using generic state, value, and set value. And we're saying set the state, so use state should come from the get state from local storage function there. The next thing is that we move the local storage updating code, which is local storage.set item, from that specific store state in local storage function into a use effect. So every time the component renders for the first time and anytime state changes, it will update local storage and it will set the item with the key and value pair that we pass it. And the dependency array has key and value. So every time key or value changes, it'll update local storage. And then finally, the use local storage hook returns a value and set value. And the way we use that is by saying mode comma set mode equals use local storage mode comma light, which is almost exactly identical to what we did earlier, but now instead of using state, we're using our custom hook mode and light. So tomorrow, if you want to use this for, what did we say, song and set song, you would say the key is song and the value is staying alive, or I don't know, I can't remember any of the, we will rock you, or whatever you want to wash your hands to. And so this way, we are reusing our code and making it much easier to call local storage anytime you want to do that with something else. But why hooks? Hooks solve three main problems. One is wrapper hell. You've probably heard about this and probably seen this in your apps as well, where you have to, like, you see the shape of code where you have element inside an element, etc. And typically React components are surrounded by layers of providers, consumers, higher order components, render props, and using hooks in functional components makes it easier to reuse stateful logic and avoid wrapper hell like this, so you don't have to pass props up and down all over the place. And then we saw a really simple example of the lifecycle methods versus use effect. And what we saw in the lifecycle methods was we lumped together code that's related, that's unrelated, and we split up code that's related. For example, if you had a component did mount where you want to do some logic for data fetching, you would sometimes have it mixed in with unrelated logic to set up event listeners. And so basically, use effect mitigates that by letting you use as many use effects as you need to, so you can componentize or modularize your code and give it more context. And finally, classes. So when I was writing class components, which I don't anymore, but the main problem I had was, annoyingly, I would completely forget the syntax, or, miss a bracket or a curly bracket somewhere, and I had to constantly look that up. I often forgot to bind my event handlers, especially when I was using regular functions instead of arrow functions. And turns out this is a fairly common problem. And also, other than humans, machines also have issues with classes. They don't minify class-related code very well, which means your code is more bulky and will take longer to load and to parse, and this slows things down and affects performance. So hooks solve that problem as well. And why custom hooks? Because for the same reason we use functions, right? To keep your code dry, to make it more reusable and more maintainable. There's a whole host of custom hooks that you can find online that are already written for you. The one we had today that you saw, use local storage, that's something that you can reuse. You'll also find things like use dark mode. And I can't think of any more examples now. My mind's a blank. But um, if you Google it, you'll find a whole ton of custom hooks that you can use in your code or reuse in your code. Um, in summary, um, hooks are com- excuse me, hooks are completely opt-in. They're backwards compatible, um, and they're JavaScript functions that you can use in functional components to hook into the React API, and to create custom hooks. Um, Thank you very much. I hope you all stay well and stay healthy. And I would appreciate any feedback you have for me. Thank you. Bye.
Hello, everybody. My name is John Linnell. I'm a full-stack JavaScript developer at ThirdBridge. My team works on various Node and React-based platforms, lots of which are kind of internal to facilitate our business workings, but some of the more major projects have been client-facing too, and those are the really fun ones to work on. So I don't think many people outside of the industry will have heard of ThirdBridge. To be honest, I hadn't until they hired me, but they play a really important role in the world of global finance. So ThirdBridge puts investors in touch with industry experts to help them make the best investment decisions. Basically, we connect people who have lots of money to invest but not sure where to invest it with industry and area specialists with loads of experience and expertise to help with their decisions. There's a little bit more to it than that, and our marketing team would probably not appreciate my rather infantile explanation, but I'm not sure they're going to be watching. So this is a slightly different format than I was expecting. I was kind of expecting to be up on stage talking to anywhere between 20 and 100 developers eating pizza and drinking beer. But instead, I am in my house talking to myself. And it's all a little bit weird, so I hope you'll bear with me for this. So without any more ado, let's just jump straight into the question. Is Redux dead? No. Wait, hang on. Yes. Not really. Yes, kind of. But maybe it is. But probably not. Right? This is all kind of a bit complicated. But it's also a not very well phrased question to begin with. If you've been on developer internet or Twitter at all in the last year or two, the question, is Redux dead, has been circulating on the internet for a while. And the only reason we're even asking this specific question in these specific terms is because the JavaScript community, much as I love it, and I really do, can be a little bit prone to clickbait and jumping on bandwagons. So controversial and reductive headlines get a lot of traction on Medium and Hacker Noon and other sources of digital detritus, and for good reason. They shock us, they challenge us and our beliefs and our competence as engineers. Like, if an article pops up in your feed entitled 10 reasons why you're using the map function wrong, the author is luring you in with some clickbait that jabs you in the self-confidence and says, hey, you call yourself a developer, but are you the kind of idiot who'd misuse the map function? The reality is that you're probably doing fine. Like, this is just sensationalist rubbish. They're trying to draw you in for clicks and stuff. So, don't believe everything you see on the internet, because it might not be helpful, useful, or even true. Exercise some common sense, some critical thinking, and despite whatever people on Hacker Noon tell you, you're probably doing fine. Right, that's enough of my opinions. I'll just climb down off of my soapbox now. Thank you for listening to me waffle. So this is a difficult question, but as with all, populist rhetoric in the world at large, there is usually a grain of truth or some undercurrent that has led us to ask such a simplistic question. So before we can answer this question, or try to, we need to do a little bit of a history recap. What is Redux? Where did it come from? Why do we use it? So ostensibly, Redux is a state management library. It allows us to describe application state as a series of plain objects, describe updates to that state as more plain objects, and use pure functions to describe how the state should change. Although you can use Redux with almost anything, Angular, Vanilla.js, you could even use it with jQuery if you really wanted to, but I don't really recommend that. It works really well with React on a sort of conceptual level. They're both quite highly functional in design, and they promote unidirectional data flows in your applications. In React land, we use it for solving one of the oldest anti-patterns in React applications, prop drilling. You have some piece of state all the way at the top of your component tree, and a bunch of nested components need to know about that bit of state. How do you get it there? You drill it down through the props, component by component, parent to child, knitting your app together tighter and tighter with each level. Redux allows you to avoid this, and that all sounds great, but why do we hate it? It's hard. This is a bad example. This is a bit more of a complicated application, and I actually ran out of space trying to fit this on my screen. There's more to it than this. It's hard. It's traditionally difficult to boilerplate. It requires a lot of extra stuff to do basically anything at all. The learning curve is regarded as being pretty steep, and until quite recently in React terms, it was largely unavoidable if you wanted to develop a front-end app to any degree of scale or complexity. So why do people think it's dead? Apart from wishful thinking. In a word, context. In React 16.3, I think it was, the context API in its current incarnation was released, and it solved the prop drilling question like that. Immediately, with just a provider, a consumer, some render props, you could pass data from the top of your app all the way down to an arbitrary number of consumers anywhere in your component tree. There's a reason everyone jumped on context as soon as the new API came out. It solves a common problem, much like Redux does, but it solves it in a much simpler way. And it does so with a minimal learning curve. And that's just not something Redux can claim to do. Like, I'm sure some of us will have had projects in years gone by before 16.3 when at some point we've looked at our data and we've looked at our component trees and we've said, oh, fudge, I have to use Redux. And then you spend the next 4 hours building your reducers and creating your stores, writing action creators, committing 15,000 lines of code at 4 in the morning and realizing that you got your enums wrong or that you can't dispatching your action creators correctly. And then you can't figure out why you didn't prefix your connector function with on, nothing works, and you throw your laptop in the canal because you just want to condemn that abomination to the depths where no one can see it and it can't hurt anyone ever again. Or is that just me? Context solves that problem. And it solves it in an obvious, easy way. It got even better with the use context hook, which makes working with context even easier and even more syntactically sugary. So, are hooks and context enough? Many seem to think that the bell tolled for Redux with that release. Immediately, one of the major use cases of the library was subsumed by a reasonably clean, built-in API that anybody could leverage with a minimal amount of pain or effort. Like, if you just want to pass some basic data that doesn't change down through your component tree, this is the way to do it. Seriously, I'm a firm believer in the right tool for the right job. Hooks and context are great for passing things like theme data, like app-wide configuration and so on, down through the tree. But when you want to manage global state on a large scale, with asynchronicity, collating multiple stores, rapidly changing data structures with middleware and so on, that's when context starts to fall flat. You also don't have one thing that I absolutely love in Redux, which is the time-traveling debugger. If you believe that your UI is a function of state, then being able to see the changes affecting your UI in a scrubbable, time-travelable sort of way is absolutely invaluable. It's a really powerful tool, and it's not something I've seen elsewhere. Context and hooks are great for some use cases, but not all. You will probably still find yourself reluctantly reaching for Redux at some point or other. It's historically been a colossal pain in the neck to use. But is that still the case? One would hope that in the marketplace of JavaScript ideas, which I guess is a thing, the Redux community would see the simplicity of these sometime alternatives and up their game a bit. And in a way they have. Redux Toolkit came out a couple of months ago, and it introduces a lot of really cool things that just make dealing with Redux so much easier. So I'm not going to go through every single one of these in extreme detail. You can have a look at the documentation yourself because it's really easy. It's so much nicer than Redux used to be, in my opinion. So it does all the same stuff, but it just does it for you. Their strapline is the official, opinionated, batteries included toolset for efficient Redux development, and that just sounds so good to me. Let's just have a quick look at some of these. We've got Configure Store, which some of you may recognize. It looks a bit like Create Store, but it simplifies the bootstrapping procedure. It gives you this configuration object that you can use for handling reducers and middlewares and dev tools and stuff like that. That's really cool. It gives you a couple of little helper functions like create reducer, which allows you to create a sort of object map or lookup table for your reducers for specific bits of state, which is nice. We have a helper function for creating action creators, but the thing that is a real game changer for me is the create slice function. And that is what I want to demo right now. Okay, so I've got a super basic React app that I flung together with Parcel, which is a really nice alternative to Webpack, I guess, especially for small projects. You should check it out. We've got our basic app. We've got our templates. We've got our index page, which is just a really basic React app. I've got a counter and some buttons, and that's these. I've got some buttons and a counter. And this is what the page looks like. So we've got an increment button and a decrement button. At the moment, there is no store. If I go on my Redux store, there's nothing here. So let's say I want to hook these buttons up to this counter. Now, obviously I can do this with a proper orchestration of local state. I don't really need Redux for this. You can do this out of the box with React. But bear with me, it's a demo. My choices were either extreme simplicity or extreme complexity. And I went for extreme simplicity because I'm a simple man. So let's hook this up. Let's use Redux Toolkit to bootstrap Redux in this project. So I'm going to shoot over to my terminal here. I'm going to yarn add React Redux and Redux.js package toolkit. And that should download these. Right. Now, I left myself a very helpful reminder to start here in the store. So I've kind of already added this file. So let's get to it. Let's get rid of that. Import configure store. So this is that help function I mentioned earlier from Redux Toolkit. Let's define our store equals config store. And here we get to provide our configuration option. So I'm going to first add some reducers. So we're going to need one for our counter. I'll explain what this means in just a minute. I've got to get my syntax right. I will explore that. Right, where does counter slice come from? Redux Toolkit encourages you to think about your store as slices of state. So that's what we're going to do here. I've got this counter slice, which I will import from slices counter. Now I need to actually create this now. So new folder, slices, new file, counter.js. Lovely. So what we want to do here is create a new slice of our store, a new slice of state. So we're going to bring in create slice from Redux Toolkit, and we'll initialize a counter slice. I will say counter slice an awful lot in this demo. Right, name. Let's give it a nice human readable name like counter. Initial state can be 0. And now our reducers. If you've used Redux before, you'll be beginning to understand why this is so exciting. So we're going to define 2 reducers here for handling new state changes. We'll have one to increment the counter, so state +1. And we'll have one to decrement the state. Is that right? No, that's not right. There we go. State -1. There we go. Make that usable. Okay, that's it. That's our state slice defined. We've got our name, we've got our initial states, and we've got our reducers. What this function will do is create action creators for us as well. It won't create selectors, so I'm just going to quickly add a selector function that we can use later on for grabbing this out of our state. There we go. We'll save all of those. And that is just not updated yet. Fantastic. All right, we're getting there. So the next thing that I'm going to need to do is add our provider. So I'm going to pop on over to the index. I'm going to import provider from Redux. Okay. And I'm just going to go ahead and encompass the whole app in this because I'm not really that fussed about best practices right now. I'll have it automatically include the store. Fantastic. And we'll pop that there. Got to get the indentation right. Okay. So let me just save that. And if I pop back to our demo now and refresh the page, you will see in the Redux DevTools that we have our state, our counter. These still don't do anything, so let's hook those up. If I go into, in fact, first, let's just get rid of that. We'll set the counter up. So import use selector, and those of you who haven't used Redux for a couple of years, that's right, React Redux now has hooks, which is just super nice. So let's pop that out of there. Const count equals use selector, and we're going to bring in the get count from the slice that I defined a few minutes ago. And now, with a little bit of luck, there we go, 0. So let's hook up those buttons. Imports will import another hook from React Redux called use dispatch from React Redux. And const dispatch. We need to create that dispatch. Right. Now we need to bring in our state. Now we need to bring in our slice of state. So import counter slice from store slices counter. And there's a reason we're doing this. What I want to do is use the actions that were automatically generated, the action creators, sorry, that were automatically generated by create slice. So these buttons both take a handle click argument. So I'm just going to write that in now. Handle click. We want that to dispatch an action. So counter slice actions increment. I've got to check these right around. Yep. Okay. And you want to call those to get the object back. Right. That should be it. Let's have a look. It is it. There we go. So with just a few lines of code, I've managed to hook up my dispatch function with those buttons and update the store. And you can see here in the Redux DevTools, these are changing nicely. Okay, so a quick recap. I've created a store in a few lines of code. I've created an object that describes how that store changes and what it looks like. And I've had some like basic reducers in here as well. I've created a display component which reads that number from the state using the useSelector hook. And I've wired up some buttons to dispatch actions to my store to increment that counter. So that's all pretty cool, but I think we can do something slightly more exciting. So the eagle-eyed among you will have noticed that I have two more components here called emoji counter and emoji selector. So here we have a component that pretty much takes a count and an emoji and then repeats that emoji a certain number of times. So that's pretty basic. And I've got another component over here which allows us to set that emoji. So I'm going to create another slice of my store. So it'll create a new file called emoji.js. We'll do all the same stuff again. So we'll import create slice from Redux Toolkit. We'll do a new slice of state. Name will be emoji. Nice and simple, nothing fancy. Initial state can be, ooh, now I have to pick a random emoji. I think this says a lot about what's going on in the world right now. I've got the working from home emoji, I've got the whale, which I use for Docker, the shrug, death, and a mask. I'm going to go for sparkles because it's nice and positive. Now let's give it some reducers. So I'm only going to have one reducer, and that's just going to be set emoji. So we'll call that set. And that will basically take the state and the action that we dispatched to the store, and it's going to return action payload. So whatever is in the payload of the action is going to set that into state. And we'll export that. Okay, and we'll bring that in here. So emoji Okay, one more thing that I need to do, I need to create a selector. So this isn't necessary all the time, but it does just make things a bit easier. So we'll create state emoji. Just really stupidly, that will return whatever we've set to that slice of state. Okay, so now if I go back and look, here we go, counter emoji. So let's add in that bit of state into our emoji counter. So this is no longer taking any props. We'll just import use selector from React Redux. So this is basically the same again. I'm going to get the emoji, const emoji equals use selector and get emoji, which is being exported by my slice. We'll do the same for count because we want the count as well. No, didn't automatically. There we go, get count. Okay. So now this should, once I refresh the page. I forgot to mount the component. That always helps. You need to do that. Emoji counter. There we go. No props. Don't need them. And there we go. So we can see the state changing over here. And we can see these changing on screen as well. Fantastic. Last thing to do. Let's add this emoji selector. So we're no longer using local states. So we can scrub all of that out. We'll import use selector and use dispatch because, you know, this is a control form, so okay. So emoji selector, we want to create a new dispatch function. It calls use dispatch. We'll initialize the value to whatever we currently have in state. Okay, and now we just need to change what this does. So we're going to have it dispatch our action creator, which we defined in emoji slice. So emoji slice.actions.set, and then we're going to give it the value of the text box in this component. I just need to import emoji slice. Is it default export? Okay, I think that's pretty much it. So I need to mount it. Need to remember to mount it every single time. Okay, so let's add emoji selector just there. And oh no, I did that slightly wrong. So I'm just going to change this. Okay, now I should be able to create some volcanoes. There we go. Pretty cool. So that's pretty much it for the demo. I've created a store in very few lines of code, created a counter, created a reducer to handle the counter, created a slice to handle some emojis, and then I've mapped it into my application really, really simply and really, really quickly. So let's just compare these two really quickly. Traditional Redux with Redux Toolkit. Traditional Redux, there's a lot of boilerplate. There's a lot of code you have to do to make it work, even slightly. It's time consuming to implement because of the boilerplating, but also because it has a very complex structure. Like I'm sure you've all seen at some point folders of action creators and a folder for constants or enums, a folder for reducers, and then it's just everything spread everywhere. The ducks pattern goes some way to fixing that, but it's not really enough in my view. And all of that makes it hard to read. So what about Redux Toolkit? Oh, it's also fragile. Forgot to mention, very fragile. If you break one thing, everything breaks, and it can be very hard to diagnose. Redux Toolkit, minimal boilerplate, as you've seen, very few lines of code required to make it work. It's quick to implement. It's incredibly streamlined. It's very easy to read, at least for me. I've been looking at it long enough. And it's much more robust. It does a lot of the fiddly bits for you, so it's more difficult for you to break something. So let's just ask ourselves that question one more time. Is Redux dead? Redux is an incredibly powerful tool with a rich ecosystem and years of high standing in JavaScript land. It solves application state in a solid, performant and easily testable way, and it provides us with fantastic debugging tools, excellent mechanics for middleware, and most importantly, it's utterly ubiquitous. Like, context is great, it provides a good solution to the prop drilling anti-pattern, and in terms of global state management and complex and data-rich applications, I just don't feel like it's quite on the same level. So, one last thing. If you were umming and ahhing about whether or not to learn Redux, I would recommend learning it, because if we're being pragmatic about these things, if you get a job with a company working on React apps of any size and vintage, there's a pretty solid chance they're using Redux already. That story about me staying up late trying to learn Redux only to find I'd done half of it wrong, that was absolutely true. I didn't throw my laptop in the canal, but I was so frustrated with this arcane black magic of Redux as a relatively new developer that I almost gave up. And that was nearly 4 years ago. If context had been an option then, I probably would have, and I'm glad that I didn't, because Redux plays a really important role in our apps at ThirdBridge, and I've grown to love it over the years. It is my go-to library for complex state management. It isn't 2016 anymore. Redux doesn't have to be the line count doubling monstrosity it used to be. But I want to leave you with just one final thought on the phrase, is Redux dead? I have a communications background. I have a BSc in Media and Communication Studies, which is obviously essential for any software developer, of course. Headlines are extremely important in the media. You can encode a lot of meaning in a headline, and they are very useful at prompting behaviours, but they can also be quite stupid and quite simplistic. There's an old maxim in communication circles, which has come to be known recently as Betteridge's Law, and it goes something like this. Any headline that ends in a question mark can usually be answered by the word no. So, is Redux dead? I'm going to leave that for you to work out. Thank you very much for watching. If you have any questions, please feel free to hit me up on Twitter, or I think you can send them in on the stream that we're going to do on the meetup. I'm not quite sure how it's going to work, but I'm sure Duncan's already mentioned it. Otherwise, thank you very much for your time.